In this example, we will learn about the zeros, roots, and x-intercepts of a polynomial function. In Part A, define 0 of a polynomial function and determine if each given value is a 0 of p of x equals x squared minus 4x minus 5. We'll begin by defining 0 of a polynomial function. Any value of x that satisfies the equation p of x equals 0 is called a 0 of the polynomial. A polynomial can have several unique zeros, duplicate zeros, or no real zeros. Now we'll test if -1 and 3 are zeros of p of x equals x squared minus 4x minus 5. Replace the function input with -1. Simplify to get 1 plus 4 minus 5. Complete the calculation to get 0. Since p at -1 equals 0, -1 is a 0 of the polynomial. Now we'll test if 3 is a 0 of the polynomial. Replace the function input with 3. Simplify to get 9 minus 12 minus 5. Complete the calculation to get -8. Since p at 3 does not equal 0, 3 is not a 0 of the polynomial. In Part B, we'll find the zeros of p of x equals x squared minus 4x minus 5 by solving for the roots of the related equation p of x equals 0. We can find zeros by solving p of x equals 0. Recall that the zeros of p of x equals x squared minus 4x minus 5 are the values of x that make x squared minus 4x minus 5 evaluate to 0. If we solve the equation x squared minus 4x minus 5 equals 0, the roots of the equation will match the zeros of the polynomial. Write the equation x squared minus 4x minus 5 equals 0. The trinomial x squared minus 4x minus 5 factors to x minus 5 times x plus 1. If either factor becomes 0, the entire expression will become 0, satisfying the equation. Set the first factor equal to 0 and solve for x. When x equals 5, the expression x minus 5 becomes 0. Now set the second factor equal to 0 and solve for x. When x equals -1, the expression x plus 1 becomes 0. The roots of the equation x squared minus 4x minus 5 equals 0 are x equals -1 and x equals 5. Therefore, the zeros of the polynomial p of x equals x squared minus 4x minus 5 are also -1 and 5. Zeros and roots have the same numeric value. Now we'll move on to Part C. Use a graphing calculator to graph p of x equals x squared minus 4x minus 5. How are the zeros of the polynomial related to the x-intercepts of the graph? Draw the graph of p of x equals x squared minus 4x minus 5. The x-intercepts of the graph of the polynomial are -1 and 5. These are the same values as the zeros of the polynomial. Now we'll move on to part D. How do you know when to describe solutions as zeros, roots, or x-intercepts? The zeros, roots, and x-intercepts of a polynomial all have the same numeric values. However, the term we use to describe them is context-sensitive. We use the term zero to describe a property of a function. For example, the polynomial p of x equals x squared minus 4x minus 5 has zeros of -1 and 5. We use the term root to describe a property of an equation. For example, the equation x squared minus 4x minus 5 equals 0 has roots of -1 and 5. We use the term x-intercept to describe a property of a graph. The graph of p of x equals x squared minus 4x minus 5 has x-intercepts of -1 and 5.